All right, what's up, guys? As promised, make a little review video for you. We should have, if you're here Tuesday, you should have the assessment notes that we did from the review. If not, here, I'll frame it for you. You can pause and kind of copy those down or whatever and get those on there. Hopefully, doing the assessment and everything, you missing Tuesday that we got all this that we needed for that. So that's the idea there. Okay, from there, let's just jump down here and let's get right to it. Just the basic patterns, these are all in numerical representation form. These ones all aren't necessarily bound to our rules that we've been using, like they have to be like the first difference, second difference, third difference, or a multiply pattern. These ones can be any kind of pattern. They can have patterns within patterns or like all kinds of funky stuff. So a lot of people I've talked to, number 6 has been a little bit of a rub. I should have put a star on that one. That one's an extra special one, but let's just take a look. So looking at my patterns here, number 2, just, I like to check out the plus patterns because I like to keep it simple at first. So plus 6 to get me from 8 to 2, plus 6. So it's looking like that's probably going to be the case. So plus 6 would be 20, and then 20 plus 6 would also be 26. So that definitely fits my pattern, so that would be it there. Let's see, over here I got a 0, then a 1, so that went plus 1. Here it went 1 to 3, so that's a plus 2. 3 to 6 would be plus 3, so I think I see the pattern now. It's going plus 1, plus 2, plus 3. I'd predict that this one needs to be plus 4, which it is, because then 4 plus 6 ends up being equal to 10. Okay, and then 10 plus 5 would be 15, so then this would need to be 15 plus 6, which would give us 21. Okay, there's that one. This one, it's like really big and then it ends up getting really small. So that should be a hint that this is a multiply pattern, because multiply patterns get either really big really fast or they get really small really fast. So this one's getting really small really fast. So it's got to be some kind of like multiply pattern. So let's see. Sometimes coming up with exactly what you're multiplying by is a little difficult. So sometimes what we do is we can come in here and we can take our calculator. Okay, we'll do this. We'll come in here, we'll say, all right, 600, okay, 600. We'll type in 600. We're going to divide it by the one right before it. So we'll divide it by 1200, okay? And that'll show us what we're multiplying by every time. So it says we're multiplying by 0.5, which 0.5 is also 1/2. So we're multiplying by a half, or basically we're cutting everything in half as we go. So 1200 to 600 would be cut in half. 600 to cut in half would be 300. 300 cut in half would be 150, and then 75. So that's the idea with that one. This one, number 4, we got 1, 2, 4, blank, 16, 32. This is 1 times 2, 2 times 2, 4 times 2 is 8, and then times 2 would be 16. So this is a multiply by 2 pattern. Let's see here. This one down here, this one looks kind of weird, like, they're bigger numbers, but they're not getting small very fast. So you might be tempted to go with the exponential pattern or a multiply pattern, but this one's actually going to be a subtraction pattern. How did we get from 480 to 458? So we can do the similar thing that we did over there. Well, we can take one of these numbers, so how about 458? We'll subtract it from the one right before it, 480. That tells us what it took to get there. So from 480 to 458, we subtracted 22. So it's minus 22. Okay. If I subtract 22 from 458, that gives me 436. So that'd be 436. If I continued that, minus 22, I end up at 414, which is what we have here. So that's a good thing. All right. That means that our pattern is just subtracting 22 every time. See, subtracting 22 is kind of random, and these are kind of big numbers, so sometimes the calculator can help us with those types. Now we can talk about this one. This one's really funky, and there won't be one like this on the test. That one's weird. Okay, well, this is how this one works out. If we do 1 times 2, then we get 2. If we do 2 times 4, we get 8. If we get 8 times 8, 8 times 8, then we get 64. If we get 64 times 16, we end up with 1,024. And then we get, if we multiply that by 32, then we end up with this 32,768. So what was happening here is there was a multiply pattern, but what we're multiplying by actually doubles every time too. So there's like kind of a pattern within a pattern thing going on. All right, let's see. For problems 8, 9, we missed 10. I don't know what happened to 10. For problems 8, 9, 11, and 12, those ones are all about arithmetic sequences. They say these things called common difference. Okay, arithmetic sequences. D is that common difference. Okay, when it says common difference, you should be thinking it's an add or subtract pattern. Like a linear pattern, okay? This is going to be, or like linear, that's a good word too, okay? This is like linear. So we're looking at that constant thing. These ones are ones where there's not a pattern in a pattern, it's just the basic ones. So to go from -2 to 4, we're adding 6. 4 to 10, adding 6. 10 to 16, adding 6. So the common difference for 8 is 6, okay? So how we get the next two terms is we just continue adding 6. So 16 plus 6 is 22. 22 plus 6, 28. All right. So that's the idea there. This one, it's just negative. We're getting smaller, so we're taking away something. 90 to 83, we're subtracting 7. Subtracting 7. Subtracting 7. So my common difference is going to be -7. Okay. Common difference can be positive or negative. I know you're tempted to think difference and think you're always subtracting, but when it's common difference, it could, if it's positive, you're adding. If it's negative, you're going to subtract. Okay, let's keep that pattern going. We got 62 when we take away another 7. We'll have 55 when we take away another 7 from that one. Okay, now a couple of word problems that are essentially like based off of these two. Suppose a pattern, an arithmetic sequence. Remember that one means add or subtract. Okay, has a common difference of 3. So that means that this is a add 3 pattern. Okay, what is the next term after 60? So what this is saying is we got this sequence. We run into 60, and then what would be the one right next to it? What would be the next one? Well, since this is a common difference of 3, we're going to add 3, so that gives us 63. Okay, and that would actually be our answer. And that's all it's asking. It's just saying, what's the next one? All right. For 12, this one's the funky one. Remember when we were doing our notes on this one? If two consecutive terms, okay, consecutive terms of an arithmetic sequence are 42 and 35 in that order, what is the common difference of the sequence? So what this is saying is we have some sequence, okay? We run into a 42, then the next one, consecutive terms, would be 35, so 42 and 35 in that order. So then it basically says, and then, okay, and then the sequence would keep going. What is the common difference in the sequence? Well, what it's asking is how did we get from 42 to 35? That's all it's asking. It's just saying, hey, what did we add here? Actually, what did we subtract? Because we got smaller, all right? Remember, we can use our calculator. We can go in here. We can say, all right, we'll take 35. We'll subtract the one right before it. That was 42. -7. So my common difference of this one, we could say B equals -7, and that would be our answer to that one. Okay? Now, for these ones, for 13, 14, 15, 16, this is kind of like the last four we did, except now these are multiply patterns. So when we see this word right here, common ratio, this is our multiply pattern. Okay? That means we're multiplying every time. This would be like an expo pattern, okay? Kind of like the other one was linear. This one's going to be an exponential. So, what are we multiplying by every time? So 1 to 5, it's always easy when it starts with 1 because it's easy to figure out what you multiply times 1. It's times 5. 5 times 5, also 25. Times 5, 125. So what we're multiplying by, that's that common ratio. That is 5. Okay, it's always what we multiply by, never but by what we divide. Notice this, if we keep going, 125 times 5 is 625. So we can do that. Okay, and then times 5, 3,125. Okay, and then we're good on that one. All right, 14, we're getting smaller here. So sometimes it's a little hard to come up with it when it's getting smaller. So we'll take 405 like this. We know it's a multiply pattern, so we'll divide it by the one right before it. That's 12, 15. We get 0.33333. Don't panic. Don't panic. Don't panic. Hit math, and then enter, and then we have this nice fraction. It's 1/3. Okay, so it's just 1/3. Okay, so we're multiplying by a third. So 45, let's do 45 times 1/3, 15. Okay, and then we can do the same thing again. We can go times 1/3, and then that's going to be 5. Okay, next two just little word problems again. So suppose we've got a geometric sequence, a common ratio of 1/4. What's the next term after 24? So we got the sequence, 24 comes up. It's a geometric sequence, which means that it's a multiply pattern. So it's just saying, what's the next one? Okay, if we multiply by a 1/4, what are we going to get? So that is 24 times 1/4, and we get 6. And that's our answer. That's all it's asking. What's the next one? Okay. 16 is just like 12. We got the sequence, 2 consecutive terms. We got 3 comes up, and then 21 comes up after that, and then dot, dot, dot. It keeps going. It says, what is the common ratio, or what is that thing that we're multiplying by? So we're going to say R equals 3 times 7 equals 21. Okay, we could also do 21 divided by 3 to figure that out. So 7 is our common ratio for that one. All right, and that's that type of problem. 17, 18, 19, actually the rest of them, those are all just like what we've been really focusing on lately, getting those differences, finding what that pattern is, and then that tells us what the function is. So what we're going to do is we just need to find that first, second, or third difference. Remember, linear is the first, quadratic's the second, cubic's the third, and what I'm saying is the first is constant, second is constant, or the third is constant, meaning the same, then that tells us what type of function it is. Exponential, that's our multiply pattern. Okay, so these ones right here, we can go ahead and do that, all right? Check out 18. 18, I told you, if it gets small really fast, you should be thinking it's a multiply pattern. And it actually is. This one, what we're doing in here is we are actually multiplying by 1/3 every time. Okay, so being a multiply pattern, you're an expo. All right, if we look here, we're going +4. Okay, we go here, +4, all the way down, it's +4. All the way down. Oh, nope, that one's +6. Uh-oh. That one's +6. Oh, no, what happened? And then this one's +4 again. Dang it, what happened there? Oh, wait. Remember, look at our x's. Look at the last one we just did. Our x's were in order. Our x's were in order. Our x's are in order. This one, we're jumping all over the place. It's +2, +2, +2, and then it's +3. Uh-oh. So remember, this is our one weird situation we're going to have. If the pattern doesn't hold the x's, what we're going to do is all we're going to check is if it's linear. And the only thing we got to do is make sure that our slope is the same. Remember, slope is change in y over change in x. So our first one was 4/2, which gives us 2. Okay. Everything else is still 4/2, 4/2, 4/2. Here's this one, 6/3 though. We got to check that. 6 divided by 3, that's 2. So that matches. Next one's 6/3, this one's 4/2. So all of our slopes match. When slopes are the same, we have a linear function. So that's our weird one. So you got one that's got weird stuff. Another thing you could do is type it into stat, like we taught you guys yesterday with the assessment. Type it into stat. Check it out. See what you get. Look at the function. See if it looks right. Okay. Look in the calculator. Okay. This is an alternate way of doing it. Let's see. We can go ahead and do this one. -5, -3. Already, I know it's not linear. -1. Let's see. +1, +3, +5. So it's not linear. First one's not the same. It's +2, +2, +2. Oh boy. +2, +2. So our second difference is the same. That makes it a quad. All right. So that one's a quad. That's making me feel like this has got to be something. It's got to be like a cubic or something. Well, let's find out. Let's see. That's going to be +19, +7. That's a no. Not linear. +1, +1. What the heck is going on here? We got +7. And then we got what is that, 19 again? Yeah. Okay, so it's not linear. Let's see, we got -12. Sorry, my bad. -12. We got -6, not quadratic. Let's see, minus 0, we got, what is that, plus 6, and then we got plus 12. Okay, so it's not quadratic, but if we were to keep going, it's minus 12 to minus 6, so it's plus 6, minus 6 to 0, plus 6, plus 6, plus 6. The third difference is the same. This is a cubic. That is a cubic. All right. All right. Which of the following graphs matches the data shown on 17 above? Well, 17 was the linear one. That one is the linear one right there, C. Okay, this one's linear. Okay, this one's squiggly, so that's the one that I called cubic. Okay, this is the U shape. That one's quadratic. Okay, that one was a linear, so this one was C. All right. Use the patterns in the tables below to answer 26 and 27. So the whole idea is what, based on the pattern, what is it? And then they got to fit like the different things. It's kind of weird. Let me just tell you, this one's linear. We'll just save some time here. Let's see, you're linear. You're not linear. What is that guy? This guy, that's a minus, plus 3, plus 3. This one must be a typo, but this one's not linear. We'll go with that. Let's see. And then U right here. Minus, oh gosh, okay. That one's linear. So that means that tables 2, 3, and 4 are linear. Let's see. Which tables represent quadratic? Well, the only one that's not linear is this one, so this one's got to be quadratic. That's A. All right, good luck on your test. Happy studying. Oops, not freeze. Oh, this is for the extra people who watch till the end. Here you go.